Back in the day, software was all about the lone genius, the developer crafting this perfect piece of logic in a single file. But let's be real, that world is long gone. The game has totally changed. Today, we're not just building little pieces of code, we're orchestrating massive, complex systems. So today, we're not just going to look at code. We're going to dive deep into the architectural philosophy that holds all of modern software together. We're talking about the art of application wiring. And this quote, it just nails it. The biggest challenge for any architect right now isn't writing some clever algorithm. No, it's figuring out how to connect hundreds, sometimes thousands of different pieces that were probably built by different teams, maybe even in different countries, into one single, resilient application. The real magic, and honestly, the real danger, it's all in the wiring. So, here's our game plan for today. We're going to start with why this whole wiring thing became such a huge deal. Then, we'll get into the philosophy that actually solves it, what's called the Hollywood principle. We'll see how the Spring framework gives us the pro-level tools for this, and then we'll really dig into the single most critical wiring decision an architect has to make. We'll even solve a classic paradox, and finally, we'll zoom out and see how all these ideas scale up to the biggest systems out there. Let's dive in. We are absolutely in the middle of a wiring revolution. Think about it. Your application isn't some handcrafted sculpture anymore. It's an assembly line. You're grabbing parts from third-party libraries, components from other teams, and your job is to make sure they all find each other and know how to talk. If you get this wrong, you're not building software anymore. You're just managing a logistical nightmare. Okay, this slide shows the problem perfectly. On the left, you've got the old way, what we call plain old Java. The car object is literally creating its own driver. It seems simple, right? But it's a total maintenance disaster. What happens when your boss tells you that a driver now needs a license to be valid? Well, the car class breaks, and so does every other single class in your entire code base that was manually creating a driver. You've basically built a house of cards. It's fragile and tightly coupled. So how do we fix this mess? Well, the solution isn't just a new piece of syntax. It's a complete change in mindset. It's about teaching our code to stop being a control freak and creating its own dependencies. It's time to learn the Hollywood principle. And that big shift in thinking is called inversion of control, or IOC for short. The idea is actually really simple, but it's profound. Instead of your code going out and creating the things it needs, a central framework is in charge of creating them and just handing them over when they're ready. The mantra is, don't call us, we'll call you. Think of it like a fancy restaurant. In the old model, you'd have to go into the kitchen and cook your own steak. With IOC, you just sit at the table and a waiter, that's the framework, brings a perfectly cooked meal right to you. Your code doesn't need to know anything about the kitchen. It just focuses on its one job, enjoying the meal. So, that's the what. That's the big idea. Now for the how. A philosophy is great, but we need a professional toolkit to actually make it happen on a large scale. And in the Java world, that tool is the Spring framework. The best way to think about Spring is as the master plumbing system for your entire application. It handles all the messy, behind-the-scenes work of connecting everything, so you can focus on what actually matters, the business logic. So how does this whole plumbing thing work? Well, we give instructions to Spring using these little labels called annotations. You can see some of them here. @component is basically you telling Spring, hey, see this class? It's an important part. I need you to create it and manage its lifecycle for me. Any object Spring manages like this is called a bean. Then you use @AutoWire to tell Spring, okay, right here, I need you to connect or inject another one of those beans I told you about. Things like @controller or @repository, they're just more specific types of components for specialized jobs, like handling web traffic or talking to a database. All right, now we are getting to the absolute heart of it. Once you've decided to let Spring handle your wiring, you have to make a choice. How exactly should Spring inject these dependencies? And I need to be really clear here. This is not just a style preference. This is one of the most critical architectural decisions you will make. It has huge downstream effects on the safety, the testability, and the long-term health of your entire application. This table gives us the bird's eye view. We're comparing the three main methods, constructor, setter, and field injection, across two things that architects care about deeply, immutability and testability. And as you can probably see, there is a very clear winner when it comes to the dependencies your class absolutely cannot live without. So let's break down why. Okay, listen up because this is the most important takeaway. Constructor injection is the architect's choice, period.
With this method, all the dependencies are passed in the moment the object is first created through its constructor. This lets you declare those dependencies as final, which means your object becomes immutable. Its state cannot be changed after it's been created. This is a massive, massive win for safety and predictability in complex systems. It guarantees you never ever have an object floating around in some weird, half-baked state. It is either fully built and 100% valid, or it simply doesn't exist.
But of course, this brings up the question I hear all the time. A developer looks at field injection, right? They see that one little @wired annotation above the field, and they think, wow, look how clean that is. It's less code. Less code has to be better, right? It is such a seductive argument, but I'm telling you, it hides a really dangerous trap. Let me just be blunt. Senior developers and architects hate field injection, and the reason is simple, but it's absolutely critical. It secretly couples your class directly to the Spring framework. If you use field injection, you can't unit test your class as a simple, plain old object anymore. You can't just write new my service and pass in some fake pest objects. No way. You are forced to spin up the entire Spring framework just to run a simple test, which is slow, it's complicated, and it completely defeats the purpose of a unit test. You have to remember this. The easiest code to write is almost always the most expensive code to maintain.
Okay, so we've established constructor injection is the way to go. But this leads to the next piece of pushback. Okay, fine, but my service needs like 10 different dependencies, and my constructor is turning into this absolute monster. That can't be good, can it? And the answer is yes, that is a problem. But it's not a problem with dependency injection.
A constructor with 10 arguments is what we call a code smell. It's a symptom of a much deeper design flaw. It's a giant blinking red light telling you that your class is violating the single responsibility principle. It's trying to do way too many things. That long constructor isn't telling you to give up on constructor injection. No, it's screaming at you to refactor your code. Break that massive class up into smaller, more focused classes that each do one thing, and do it well. You see, constructor injection isn't just a wiring tool. It's a design tool that actively forces you to write better, cleaner code. So, we've pretty much crowned constructor injection as our champion. It's safe, it's testable, it promotes good design. But what happens when we run into a problem that even our champion can't solve? I'm talking about a genuine paradox, the classic chicken and egg problem of software, the circular dependency. So here's how this nightmare unfolds. Imagine Class A needs an instance of Class B to be created. Simple enough. But at the same time, Class B needs an instance of Class A to be created. Now Spring is totally stuck. It's in a deadlock. To create A, it first needs B. But to create B, it first needs A. It's impossible. It can't build either one first. So it does the only sane thing it can do. It gives up and throws an exception, and your application crashes on startup. And this, right here, is where our second type of injection gets its moment to shine. The solution to this very specific paradox is setter injection. Now, it's not our first choice for everyday use because we lose that awesome immutability we talked about, but it is the perfect specialized tool that we need to break this specific kind of deadlock. Let's walk through how this actually breaks the cycle. With setter injection, Spring completely changes its strategy. First, it creates an empty, half-baked instance of Class A without its dependencies. Then it does the exact same thing for Class B. Now that both objects technically exist in memory, Spring can finally go back, call the setter method on object A to inject B, and then call the setter on object B to inject A. And just like that, the deadlock is resolved, the cycle is broken, and both objects are now fully wired up and ready to go. Okay, deep breath. So we've pretty much mastered how to wire components together inside a single application. We know how to build robust, loosely coupled systems. But modern architecture demands that we start thinking even bigger. The exact same principles that we just learned now apply to connecting entire applications to each other. This is the next frontier of wiring. But first, a really quick but important distinction: Spring Core versus Spring Boot. Spring Core is the engine. It provides the fundamental plumbing, that dependency injection container we've been talking about this whole time. Spring Boot is a layer that sits on top of that, and it makes intelligent, opinionated guesses about how you want everything configured. It basically saves you from a world of complex setup. By making all the internal wiring so dead simple, Spring Boot frees up architects like us to focus on these much bigger, external wiring problems. And that brings us to the two big architectural philosophies of our time. On one side, you have the monolith, a single unified codebase. It's super fast to get started with, but it can become a one-language prison. And if you need to scale, you have to scale the whole thing at once. On the other side, you have microservices, breaking the application into a bunch of small independent services. This is really the ultimate expression of that loose coupling we've been aiming for. You can use different languages, different databases, and scale each service independently. The new challenge, of course, is wiring all of them together. And that really leaves us with one final big question. We have spent this whole time mastering the art of wiring components inside a single application. But in a world that's moving towards microservices, how do we take those exact same principles and apply them to wire entire applications together across a network? That is the next great architectural challenge. I hope this deep dive has been helpful. Thanks so much for watching.